Hi, this is Prab from Summit Software Solutions, and I'm going to be giving you an overview of NoSQL today. So let's jump in. So, what exactly is meant by the NoSQL paradigm? So, NoSQL is an alternative to the relational way of looking at data. RDBMSs like Oracle, MySQL, and SQL Server use the relational model, right? So you create tables and you try to define relationships between these tables, and that's the relational way of looking at it. NoSQL is an alternative way, right? So NoSQL is very suitable for unstructured data. And when you talk about unstructured data, it refers to all the big data that is coming out from websites like Amazon, Facebook, Google, and NoSQL databases enable persistent storage for such unstructured data. And you don't really have to use the structured query language to manipulate any of this data, right? And as many of us know, NoSQL is an acronym for not only SQL. Right. So the key point that you have to remember here is that NoSQL adheres to something called the CAP theorem, right? Whereas RDBMSs adhere to the ACID way of looking at data. So I'll be going into the CAP theorem further down in this video, but for now, this is a key point that you should bear in mind. Let's look at some of the characteristics of data, which are best suited for NoSQL databases. So like I said previously, NoSQL databases are very suited for storing unstructured and semi-structured data. So you have a lot of unstructured big data coming out from the various web applications that are out there today on the internet. And NoSQL databases help you to enable persistent storage for all this unstructured data without defining any form of schema, right? So NoSQL databases are schemaless. You don't really have to define a rigid structure upfront. You don't have to decide the number of tables or the structure of each and every table. They also help with evolving database designs. So for instance, there are several startups today which want to get their product out into the market very fast. So they come out with maybe the first version of their database, and then they send their product out into the market. They get some feedback and they try to refine their database design, and that's where NoSQL databases are really helpful. They help in quick development of an application, right? Another key point that you should remember about NoSQL databases is that they are very suitable for horizontal scaling. Data can be distributed across clusters, they can be distributed across nodes, and that's really very challenging with RDBMSs, right? And let's now move on to some of the NoSQL data models. So there are four main data models. So you have key value pairs, you have document databases, you have columnar databases, and you have graph databases. So when we talk about key value pairs, this is something like a JSON type of notation where you have a key and a corresponding value for the key. So if you want to look up a value, you use the key name to look up the value, right? Columnar databases like HBase organize data in the form of columns and column families, right? Graph databases like Neo4j are useful for modeling relationships, in social networking websites. So for instance, you have websites like Facebook where there's a lot of interconnected data, and that's where graph databases come in very useful, right? So let's quickly look at an example of MongoDB. So MongoDB uses something called collections and documents. So if you try to look at a parallel in an RDBMS, a collection is equivalent to a table in an RDBMS, and a document is equivalent to a record in an RDBMS like MySQL. So if you look at document 1 here, the example of document 1, so it's got two keys, first name and hobbies. So first name has a value of Tony, and hobbies is an array of strings: sleeping, eating, and coding, right? So now if you think of MySQL table, right, this table would have two fields, first name and hobbies. So now if every record that you want to store would only be able to accept first name and hobbies, right? But now with MongoDB, you can actually define a second document which has not just first name and hobbies, it also has the last name and date of birth, right? This is not going to be possible in a RDBMS like MySQL. You will have to alter the table structure, but here with MongoDB you don't have to alter any structure. So it's pretty pretty obvious here what is meant by schemaless, right? And this is very helpful for evolving database designs, like I said. Okay, let's move on. So before moving on, one key point that I want to reiterate here is that collections are equivalent to tables in RDBMSs. Okay, and documents, of course, are equivalent to records in an RDBMS. All right, so when do you use an RDBMS? So here there's the example of two tables here. So one table has just the account number and balance, and the other table has the account number, first name, and the last name. Right. So the link between the two tables is the account number, and that's the foreign key. As you can see, there are at least in this example, there are two account numbers, 1001 and 2089, which are also found in the second table, right? So an RDBMS is actually very useful when you have some well-defined schema like this, as in this example, when you have some well-defined schema and you have data actually which can suit the schema, which can actually obey this strict schema. Now you also will use an RDBMS when you can actually see a relationship between all your data. You can actually organize it into tables, and you can kind of normalize the data across different tables. You can form a link between tables, right? So that's when you go in for an RDBMS. And of course, if you want to have very strict consistency requirements, so like let's say for instance you are depositing money into your bank account, right? And you want to see your bank account getting updated immediately. When you check your bank account on the internet, you want to see that, well, I deposited $100 into my account at the ATM, and then when you check online, you should see that $100 appearing on your bank account. So you have very strict consistency requirements with banking applications. So that's when you would go for an RDBMS. Similarly, an RDBMS is very useful if you want to kind of, come out with, say, maybe complex reports, or you want to kind of present a report which is going to use complex queries, then you would use an RDBMS. Right. So let's recap. RDBMSs can be used where applications try to follow the ACID paradigm, right? So when I say ACID, it refers to atomicity, consistency, isolation, and durability. A very good example is a banking transaction, right? So when you make a deposit or when you make a withdrawal, the transaction has to succeed, and only when that transaction succeeds will the database get updated. So if, let's say when you're withdrawing some money from the ATM, and there's a power shutdown and your ATM just shuts down as well, now the database transactions shouldn't succeed because you haven't got any money in your hands, right? So it's all or nothing. So it's only when the application completes the transaction that your database should be able to also reflect that change. So that's the meaning of atomicity. With regards to consistency, what it means is that, for instance, let's say you make a change through your web application, and one of the nodes gets updated. And there's a node, so there may be three nodes, one node in New York, one node in Delhi, and another node in Bangalore. So by consistency, it means that you should see the same view of data across all these nodes. So whichever node your web application is connecting to, you should be able to see the same value, or the same value in your bank account. So for instance, if you're browsing, say, in New York, and it connects to the New York node, and you see $1,000 in your account, and then you connect to the node in Bangalore, and it says you only have $800, so that's not consistent, right? So that's where an RDBMS has to very strictly adhere to the requirement of consistency. With regards to isolation, it means that you have multiple transactions happening concurrently, and none of these transactions should clash with each other. So you may be depositing money into your friend's account, and your friend may be withdrawing money from his account at the same time. Now at the end of the day, these two transactions have to be isolated, right? So you cannot deposit money and your friend could be withdrawing money at the same time. The bank application has to ensure that the balance is proper at the end of the day, right? So if you have deposited $100 and your friend has withdrawn $100, at the end of the day there's no change to the bank account, right? So the two transactions have to be isolated, right? And there should be a consistent view of the data. When you're talking about durability, it refers to things like, the database should be able to withstand any failures. So there might be maybe a shutdown in an extreme case. Say power is lost to the database server, so the database should be able to manage these types of failures, right? So RDBMS comes in very useful for banking applications and credit card transactions. So whenever an application has to follow the ACID paradigm, you have to use an RDBMS. Okay, so let's now jump into when should I use NoSQL. NoSQL, as I said, is very suitable for large volumes of unstructured data, right? And it also doesn't adhere to any schema. NoSQL database can actually help out when you don't really have any sort of schema defined upfront. You don't really have the structure of tables defined upfront. You don't have fields defined upfront. So that's where NoSQL helps. NoSQL databases can scale very well horizontally, right? They can be used in distributed applications. They can be used to distribute data across nodes, across clusters, right? Which is not the case with RDBMSs. RDBMSs don't scale well horizontally. They only scale vertically. They can scale horizontally, but it is very challenging. And of course, NoSQL databases are very easy to develop with. You can actually get a product out into the market faster than when you were developing with an RDBMS. Okay, and startup companies with evolving data models, they definitely find NoSQL very suitable for their requirements. The key point that I want to bring out here is there's a lot of data which is being stored. I mean, now, for instance, you make a purchase on Amazon, all that information is being stored by Amazon. All the purchases that you make, purchases that are made by your friends, and all this data is stored on Amazon. There's a lot of archived data, and they run a lot of applications and analytics on all this archived data. So that's where NoSQL comes in. NoSQL actually helps in storing, enabling persistent storage for all this archived data, right? And as I already mentioned, graph databases are very helpful when you actually want to model interconnected data. So social networking websites where there's a lot of interconnections happening, all this can be modeled using graph databases. Okay, so what about the future? I mean, are you going to be using only NoSQL? Are you going to be using only SQL? No, there isn't really a very clear-cut answer for this question. So the future, it's going to be something called polyglot persistence. So your application might have to use NoSQL for certain cases in certain scenarios, and it might have to use SQL for the other cases. So depending on the scenario, depending on the use cases, you might have to use RDBMSs or NoSQL databases. Okay, so the key thing that you should remember is that SQL databases are vertically scalable. So you can keep adding CPU, or you can keep adding memory, and help in increasing the power of your database server if you're running an RDBMS. But it's really challenging to horizontally scale an RDBMS. So many of us have heard of Oracle clusters, Oracle REC. It is possible to actually try and horizontally scale, but it's almost a black art. It's not really that easy to scale an RDBMS horizontally. But with a NoSQL database, it's very easy to scale horizontally, right? And then doing joins across nodes can be very challenging if you're using an RDBMS, right? Joins across different nodes is extremely difficult. Okay, so let's now start looking at how you should actually use NoSQL. So like I said in the very beginning of this video, NoSQL databases adhere to something called the CAP theorem: consistency, availability, and partition tolerance. And NoSQL databases, by their inherent nature, they are very useful for distributed applications, and they can be distributed across, data can be distributed across nodes. So they definitely tick the box for partition tolerance, right? They are very suitable for distributed applications. So in other words, they are partition tolerant. So that's one requirement which has been fulfilled by NoSQL databases. So now you are left with deciding between consistency and availability. So the CAP theorem says that you can either be consistent or you can be available. You can't be both, right? So like I said, NoSQL databases are horizontally scalable. You just keep adding new nodes to your cluster, and by their nature they are partition tolerant, right? So you have to choose between consistency or availability, right? So let's look at one sample architecture, right? With this architecture, it's highly available, but only eventually consistent. So, and I'm talking about a NoSQL database. So we have three nodes here: one node in Trichy, one node in Bangalore, and the third node in Melbourne, right? And you obviously there might be a web application or a web application client, or maybe a mobile client, which is talking to any of these three nodes, and that depends on where the request is routed using the load balancer. So in this case, data is replicated across all the three nodes. So you have the same piece of data. As you can see, you have name Joe, the person with the name Joe. His data is replicated across all the three nodes, right? So this architecture is highly available. Even if let's say the Bangalore node goes down, the Trichy node and the Melbourne node would still be able to service the request. So it's highly available. But assume the scenario where the Trichy node, an update is made, right, to the frequent flyer points. So as you can see, the key Joe is actually updated to have frequent flyer points of about 4235. But as you can see, because this is a NoSQL database, it doesn't get updated immediately in the other two nodes in Bangalore and Melbourne, but it will eventually get there. The update would eventually reach the Bangalore and Melbourne nodes. But by the time the update happens in those two nodes, if somebody queries the database and the request goes to the Bangalore node, they would be getting some stale data. So this is a trade-off that you would have to make. So even though an update is made to one of the nodes, the update doesn't appear immediately in the other nodes. But the advantage is that if one of the nodes goes down, your application is still up and running, and that's where you are available but you're not consistent. Okay, so let's look at architecture 2, where you can be consistent but you cannot be highly available. So in this case, you have once again three example nodes that I've shown here, and as you can see, there's no replication happening here, right? So if an update is made to the key Joe, and if an update is made to, say, the Trichy node, any request for the key Joe will be immediately presented with the latest snapshot of data. Why? Because there's only just one copy there of this particular record. So it's highly consistent. So this type of an architecture is highly consistent. Wherever the request may come from, you only have one copy of that data, and that record has been updated, or that document has been updated, right? But if in case the Trichy node goes down, your clients would not be able to read any data that's having the key Joe, right? So your availability requirement is not satisfied, but you are consistent. So when you make an update to the database, that update is immediately available to any client, provided all the nodes are up and running. But if any node goes down, the problem is that you may not be able to read the data that you want, but you are still consistent, right? So this is the second way of setting up a NoSQL database. Of course, there are a whole lot of architectures which can be made out in terms of either of these two architectures. But yeah, these are two ways of actually configuring a NoSQL database, right? So in future, if you are thinking of taking the NoSQL route, what's the type of architecture that you should be going in for? That ultimately comes down to your business requirements. So you should either choose between consistency and availability, and that's purely driven by the business requirements of your organization. So if they want all the nodes to be available at all times, then you would have to choose the architecture where availability takes priority. But if they don't want availability, but they want the data to be always fresh and never stale, then you should go the consistency route, right? So that's it, guys, and I hope you have learned something from this video. If you like this video, please subscribe to my channel, and watch out for more videos on software development, project management, and similar stuff. Of course, if you're looking for help with projects, you can visit us at our website or email us at the email ID that's mentioned there. Stay tuned for more videos of this type. See you then. Bye bye.